Hey, hello, 121 students. I was asked to make a little helpful solution here, so I'll work through these. I guess I'll divide it into three videos. It's got three different, excuse me, three different questions, and I'll do question number two first here. So let me write here number two and see what it says here. It says a planet has two moons which are on opposite sides of the planet. So I'll make kind of a bigger planet here and over here. I'll consider this number one, and so there's moon number one, and over here, this is moon number two. Okay. The gravitational force from the two moons cancel each other out. All right, well, I'll pause right there. We know the force of gravity. Excuse me. Again, let me take a drink here. Okay, hopefully that'll help. So there is going to be a force between the planet and moon number two, so that'd be this one here. I'll call that force number two. And then there would be a force between the planet and moon number one, so I'll call that number one. But that phrase, let's see, how did it say it right here? It says the gravitational force from the two moons cancels out. So that is saying that force number one is equal to force number two. Because when they cancel out, they have to be equal in magnitude and opposite in direction. Now, the opposite in direction is laid out because of the positions of the moon. So we don't have to worry about that. But the force then is what they're after. So the force between these two, and maybe I'll just call M1 here and M2 here and M sub P here for the planet, would be Newton's universal law of gravity, which would be the mass of the planet times the mass of moon 1 divided by the distance separating number 1 from the planet, so I'll call it R1 squared. And that has to equal to g times the mass of the planet times the mass of the second moon over the radius squared of number 2. Number 2 being the distance between the planet and the second moon. All right. And it looks like some things will cancel off. Maybe I'll do that now, but we need to read the rest of the question. Okay. Cancel each other out, producing a zero net force on the planet. Okay. Moon number 2 has a mass that is 3.79 times larger than moon number 1. Okay. So what that has told me, let me just kind of simplify here. So here's mass number 1 and radius number 1 squared, and mass number 2, radius number 2 squared. If I rearrange this by putting the masses together, and so I'll put mass number 1 over mass number 2. That means on this side I'll have radius number 1 squared over radius number 2 squared. So this ratio of their masses is really what was just described here. It says moon number 2 has a mass which is 3.7 times larger than number 1. And maybe I should have put them in the other order, because this is really saying number 2 is 3.79 greater than number 1. And so I'll write it as mass 1 on the top, and on the bottom I'll write it as 3.79 times mass 1. And so mass 1 cancels off, and you have this ratio of 1 over 3.79. So that's kind of the picture here of or what I've got so far here is mass number 2, which is this time larger. And then moon number 2 is blank times further away. Okay. So then I can come over here and write this as R1 over R2, and I'll just take the whole quantity squared. So I'll just put this as a ratio and then factor the whole ratio. Because what we're looking for is something that says this: radius number 2 is so many times bigger than number 1. See, right, moon number 2 is blank times further away than number 1. Okay, so I guess I'm looking for this ratio R2 over R1. So if I take the square root, I get an R1 over an R2 on the right-hand side. And on the left-hand side, maybe I'll just do it this way. I don't know if this is better or not. I'll just write it as the square root of 3.79. And I'm almost there. I just want the reciprocal of that. So I really want R2 over R1, and the reciprocal of that is the square root of 3.79. So grabbing my calculator, I'll take the square root of 3.79, hit enter, and get about a 1.95. So that's what they would be looking for, and it looks like in the solution guide, there it is, 1.95 further away. Almost twice as far. Now remember, it follows an R-square pattern, so it kind of makes sense that if one of them is about twice as, mass is 4 times as big, so not quite a 4, 3.79. Then the distance would be the square root of that, which square root of 4 would be 2. So this would be a little under 2. And sure enough, we have an answer a little bit under 2. All right. Hope that one was helpful.